So let's look at a couple of examples of how this works. So let's take the sum from n equals 1 to infinity of minus 1 to the n minus 1 over n squared, which in the previous example you'd have seen is in fact convergent. But now let's look at it in absolute value. So we take our sum from n equals 1 to infinity, and we look at the absolute value of minus 1 to the n minus 1 over n squared. Again, an absolute value. So applying the absolute value to the negative 1 to the n minus 1, the alternating series part turns it into this. The sum from 1 to infinity of 1 over n squared, because the terms are now always positive because of the absolute value. So this we know is convergent. As a p-series. So we see that this particular example is absolutely convergent. Or as I like to say, sometimes it's super convergent. But that's just my terminology. So there's an example of an alternating series where we put it in absolute value and it turns out to be a convergent series. And so we say that it's super convergent or that it's absolutely convergent. But let's look at another example. And here's what we have, the sum from n equals 1 to infinity of negative 1 to the n minus 1 over n. And again, we'll put it in absolute value to determine whether or not it's absolutely convergent. So the absolute value, minus 1 to the n minus 1 over n. Now again, from the previous example, we see that this is a convergent series. But when we put it in absolute value, again, the absolute value will take away the plus minus, the alternating portion of the series, and make everything positive. So we end up with a series that goes from 1 to infinity of 1 over n. And in this case, we know that this is divergent because it's the harmonic series. So it's possible to be convergent and not absolutely convergent. In this case, when we tested our original series, we saw that it was not convergent when we put it in absolute value. So this is not absolutely convergent. And again, the lesson here is that it's possible to be convergent, but not absolutely convergent. However, the other direction is true, and that is that if it's absolutely convergent or superconvergent, then the series is convergent. So this gives us the ability to use absolute values as a way to determine whether or not a particular series might end up being divergent or convergent based on what happens in absolute value. Again, we can't go the other way, but we can use it as a tool to help us determine whether or not our series is going to be convergent or divergent. And that's typically how we'll use it.